Hi everyone, welcome to the GOTO Book Club. My name's Guy Harrison. I'm a database author and professional, and over the past year I've had the pleasure of working with Ben and Jesse on the CockroachDB Definitive Guidebook by O'Reilly, which you should be seeing on your screens now. It's available for pre-order as we record this and should be available for purchase in April. And today I've got the pleasure of interviewing Ben Darnell, the CTO and founder of Cockroach Labs, I guess co-founder to be strictly accurate. And we're just going to talk about CockroachDB, a little bit about the book, and just give you a bit of a teaser of what CockroachDB is about and why you might want to buy the book. So, Ben, hi, good to see you, as always. Ben's in New York, by the way, and I'm in Melbourne, Australia, so this is an international call. So Ben, why don't we start with a bit of a life story from you? Could you just let us know, how you got into the industry and what you've been doing up, before founding CockroachDB?
Sure. So I started my career about 20 years ago now at Google, and that's also where I happened to meet Spencer Kimball and Peter Mattis, who would go on 15 years later to be my co-founders at CockroachDB. But anyway, at Google, I worked a lot on different sorts of infrastructure projects, including writing an ORM for Google's sharded database that powered their advertising system at the time. And then I spent a good chunk of my time there on Google Reader, where I was on the founding team and built the original backend for that system. I left Google in 2009 and went on to a number of startups, including FriendFeed, which was acquired by Facebook. And then Brizzly, Dropbox, a little startup called Viewfinder, where I got back together with Spencer and Peter, and then that startup got acquired by Square. And so through all of those different companies that I named, they all had one thing in common, which was that they were all using sharded MySQL as their main as one of their primary data stores. And so I got to see, how all the limitations of that approach, and as did Spencer and Peter. And so actually, while we were building Viewfinder, we found ourselves kind of dissatisfied with all of the database options that we were seeing out there, having been kind of spoiled by Google's GFS, Google File System, and Bigtable, and other highly scalable and automated data storage systems. And so we kind of were kicking around this idea for something that Spencer decided to call Cockroach, that would be a scalable and indestructible data store. And we didn't start work on it then because we had our hands full building what we hoped was going to be the next big mobile photo sharing app. But when that didn't pan out, and we found ourselves at Square facing a lot of the same difficulties around sharded databases, we decided that it was time to dust off that old design document and actually build it, and subsequently build a company around it and bring it to the market.
Yeah, that's fascinating. That's not the first time I've heard someone say they were building an application and realized they needed a better database, and in the end sort of pivoted around to making the database the product, not the application. In fact, that's MongoDB's story in a way, not that we still necessarily love MongoDB at CockroachDB, but they also were building a sort of a platform and then decided that they would spin off the database side of it. And by the way, Ben, I've never mentioned this to you, but I was an avid Google Reader user. I almost cried when it was deprecated. Every day I'd use Google Reader to keep up with things, and that was a sad day for me, but people won't remember that now. But this is an RSS reader that was sort of collating everything from the web that you might want to sort of be interested in. Even pre-Twitter, I guess it was, right? It was a...
Yeah. Google Reader launched in 2005, and Twitter wasn't for a couple of years after. So, Reader never had the scale of fan base to really hold the attention of a behemoth like Google, but it does have its very devoted fans, and I do hear from time to time, even today, about people that miss it now that it's gone.
Yeah. So you were saying that at Google, obviously Google pioneered a lot of stuff that led to open source and other database products. So Hadoop sort of like flowed out of some work at Google. But you were sort of inspired more by Google's Spanner database. That's was it called Spanner at the time, or were we talking about something sort of pre-Spanner?
That's right. So I want to distinguish what I actually used at Google was Bigtable. And then towards the end of my time at Google, they were starting up this new project called Spanner. And then, in 2012, they published a paper about a lot of the details of Spanner, and that really became a big inspiration for CockroachDB. So in Spanner, you see this. You see a lot of the same design elements around using data that's been broken up into different segments and doing distributed transactions across those segments to give you a very high level of consistency in a very broadly distributed system. And then subsequent additions to Spanner added SQL capabilities, and that has. That was kind of our first guiding light as we were building CockroachDB, was trying to build Spanner for the rest of the world.
Yeah, and correct me if you think I'm wrong about this, but really the sort of the key idea behind Spanner was that it was possible to keep consistency in a distributed system. Up sort of around about 2008, 2009, there were a lot of databases that threw consistency away. And so we got the term eventual consistency. It was just too difficult to maintain everything in sync in a sort of like an always up, globally distributed network like the internet. And so Amazon pioneered Dynamo, and Dynamo sort of like concepts from Dynamo came into a lot of databases like Cassandra. And the idea was it doesn't matter if things aren't right, as long as they're fast and available. And Spanner, I guess the Google sort of rebuttal to that was, we'll just make it so available that it won't really matter. Yes, it still technically might fall over in order to preserve consistency, but we'll make that so unlikely that no one will care. Do you think that's a fair sort of summary of what the idea was?
Yeah, I think that's exactly right. I think looking at another couple of Google storage systems, Bigtable, which I've already mentioned, was an eventually consistent system, and one thing that a lot of teams at Google found is that actually sometimes you do need a high level of consistency. And so there was a kind of an add-on called Megastore that ran on top of Bigtable and then gave you transactions. But because it was this layer on top, it was really pretty inefficient. And it was, it was something that you had to, really think about whether it was going to be worth it to use it. But when Spanner came along, I think the key thing, I think for Spanner and for CockroachDB that both of these products bring to the table is the idea that if you embrace the need for the strong consistency and distributed transactions from the beginning and build them directly into the database, you can do a much better job on it than if you start with an eventually consistent system and then try to bolt on some sort of lightweight transaction mechanism on top of it, as a lot of the recent non-SQL systems have been learning. And so, speaking for CockroachDB, we have our full distributed transaction implementation, providing serializable isolation, that is competitive with the read committed isolation levels that you see in a lot of other products, because we really made that a key design goal was to make the best in class consistency and isolation and other transactional properties. We made that a priority from the beginning.
So when you kicked off in 2016, is it fair to say that no one was offering a distributed sort of consistent database, other than inside of Google? Were you sort of like unique at that point?
We were not totally unique. I think the closest the closest kind of peer competitor to what we were trying to do at the time was FoundationDB, and so I believe in 2017, Apple did us a huge favor by acquiring FoundationDB, which both gave us gave the idea that we were pursuing a lot of credibility, because it showed that this kind of distributed transactional database was a really valuable thing. And so they gave us a lot of credibility for that, and removed what could have been one of our bigger competitors from the market. So thanks Apple for that little move.
Yeah, yeah. Yes, it's a lot of there's a lot of luck in software startups, right? You can sort of you can be completely right, but in the wrong time, or some little event like that will remove a barrier that otherwise might have got in your way. I can't imagine how ambitious you need to be to launch a database company. Given products like Oracle have been around for 40 years, more than that, really. Oracle's probably coming up to its 50th anniversary of version 1 or something like that. Is that right? Yes, it is. It's 78 maybe. Anyway, long time, right? And they've got layers and layers and layers.
78 is 44 years from now, so getting close.
So, but you guys sort of seem to hit the ground running, I guess. Is that because you started with a sort of a simple concept and then sort of laid your way to where you are now? Or, you can't come out of the gate running with all the features that you need. So how difficult was it to sort of, launch and get early adoption and so forth?
Yeah. So, as you say, databases are hugely complex products. The incumbents in the marketplace have had decades of experience building and refining their systems. People have really high expectations, especially when you're aiming to be kind of a transactional and operational database that's really in the most mission critical parts of your system. So it's been a difficult hill to climb. But I think that from the beginning we can offer we were able to offer some compelling and unique features. From the kind of self-healing and hands-off administrative capabilities that we offer, to the ability to run in a geographically distributed fashion, which is really one of our more unique capabilities. The history of the NoSQL databases, they showed that you can strip your feature set way down and still get something that a lot of people will be able to make use of. So we early on, we just had to be very transparent about what our limitations were. Early versions of CockroachDB, for example, had warnings in the documentation about how you probably shouldn't use joins, which are a core capability of SQL. But because early on we didn't have an optimizer that was able to execute joins efficiently, and so we had to warn people to stay away from them when performance matters. But that's something that you can live with. It's not ideal, but if you value the other parts of the product enough, then it's something you can live with and work around. And NoSQL showed that, because most of the NoSQL systems didn't have anything like joins, at least not at first, and you can still work with those. So it's the product management adage: if you're not embarrassed by your version 1, you ship too late. You just have to ship something basic that ticks all the boxes for one type of user, and then expand from there.
Yeah, that's fascinating. So in a way, if you tried to launch before the NoSQL databases had come out, you might have been laughed out of town. But when you launch and you're comparing yourself against, I guess in 2016, MongoDB had no joins and Cassandra still doesn't have joins. And so you're sort of, you're in a position where you can, which is what you did. You basically started out as a NoSQL, you didn't have a SQL language implementation. So you're able to sort of grow into that niche. Whereas I think prior to the sort of 2010s, you really had to have a complete SQL implementation from the beginning to get any adoption. But anyway, we're sort of like, we're dwelling a bit on ancient history. 5 years later, CockroachDB has a absolutely complete SQL implementation. In fact, it's as feature complete as any database I've worked with. There's no sort of obvious gaps in what you can do with it. And you guys are powering along with adoption. And I think, I'm not a member of the CockroachDB company, but I think most outside observers would admit CockroachDB is one of the leading database innovators anyway around today. So, when we look at CockroachDB today, a distributed SQL-based operational database with very high availability and complete SQL language implementation. What do you think? When do you think developers, when they're starting, when do you think they should be thinking this is a job for CockroachDB versus, I don't know, this is a job for Postgres, for instance? What is there some class of application that you're particularly focused on, or do you feel like it's a general purpose database that can be used for anything?
So my engineering answer is that it's a general purpose database that can be used for anything, but I know that that's not a very useful answer to a lot of people. So, talk about some of the types of customers that we have the most success with. I think our emphasis on strong consistency makes us kind of a natural fit for financial services. Anything where data inconsistencies can have real financial effects. But what we see, especially because banks and other big financial services are very heavily regulated, they're very risk averse, they're very slow to adopt new technologies. But what we see is actually very strong adoption in kind of adjacent fields. One area that has been a surprise for us has been in the space of gambling applications, which is it makes sense when you think about it, because what a gambling application does is broadly very similar to a lot of things that a bank would have to do, in the sense that it's maintaining ledgers and moving money from one account to another. Everything is very important in terms of getting all the bits of data right and not having money disappear or appear out of thin air. But they're regulated. They are regulated very heavily, but they're regulated in a very different way. With banks, they're regulated to be very risk averse, so that if you're a bank, you basically can't ever go down, because that's obviously very bad for your customers. The regulations around gambling are much less risk averse in that sense. There's still regulations around data data accuracy and that sort of thing, but it's in some ways it's a looser environment, and so we've been able to get kind of a foot in the door in this industry and use it to kind of hone the features of the product that are appealing and necessary to banking and other kind of bigger name financial applications and companies. And so that's been a really interesting pathway that we kind of stumbled across this segment of the industry, and it's been very fruitful for us.
Well, yeah, that's great. What about general web apps? Are people using CockroachDB just as a general purpose database? If I'm building a sort of like a web application, I can pretty much build it on anything nowadays. And what we haven't mentioned, for those who don't know CockroachDB, is it's Postgres wire protocol compatible, which means that you can use all of the Postgres drivers. There's no sort of like specific CockroachDB application stack that you need to use. It's broadly compatible with a lot of stacks that are that support PostgreSQL. So it's pretty easy to use. I can just install it on my laptop, or I can get a cloud service and I can start building apps on it, just as I could with Postgres itself or MongoDB or MySQL or what have you. Is there any sort of like reason not to use Cockroach as a sort of like in those scenarios? It's got a lot of features, but are those features holding you back when you just want a sort of like a simple database service that supports SQL?
No, I think that one of the great things about Cockroach is that it's a database that can be a good fit for you on day one and can scale out with you even as your application or business expands worldwide. So I think from day one you can setting up CockroachDB can be a lot easier than setting up it may not be as easy as just doing an apt-get install Postgres to get a basic single node Postgres server running, but by the time you add in in replication and backups and all the sorts of things that you need to do to make a Postgres instance really production ready. A lot of those things are are a lot simpler when you're dealing with CockroachDB, because we have replication built in as a core first class concept, and you can do auto scaling and rebalancing and things like that automatically. So even from the very beginning, it can simplify your operations. We don't scale down quite as small on minimal levels of hardware as a lot of the kind of traditional monolithic databases do, and we're certainly not competing in the same space as SQLite or something like that. But when you look at our cloud offering with CockroachDB serverless, it can be an incredibly affordable way to go, even for very small applications. CockroachDB serverless has a fairly generous free tier where you can get a cluster set up for free and just start using it. And then we also have, and then once you exceed the limits of that free tier, you just put in your credit card number and get billed based on your actual usage. And so that can be a very affordable option in comparison to a lot of options that would have you running a dedicated virtual machine 24/7 and paying for those costs.
Yeah. Yeah, I'm building an application now that it started off using MongoDB as the back end, but after working on the book with you, I thought I might as well just try serverless CockroachDB. And honestly, it was the least complicated thing about setting up the environment for the application. I just had to sign up, download a certificate and connect to the server, and I don't even notice that it's. I don't notice the database. I just, I send SQL requests and I get data back, and I don't have to worry too much about all of the complexities that we've been talking about. But I know that if I need it to scale globally, that I'm in a position to do so. And I think, also when you're thinking about cloud databases, a lot of the latency is going to be in the network anyway. So you might have a database at the back end in the cloud that's sort of like got a little bit of extra overhead because it's doing so much more in terms of replication and availability and so forth. But it's going to be sort of like minimal compared with the amount of time it takes to get data across the network. And so you're not going to notice it. At least that's been my experience. It's performed great. Okay, well, so the move to cloud, I guess, when you guys started, like most vendors 5 years ago, your offering was on-prem. Now there are sort of two flavors of cloud offering. Do you want to talk a little bit about the cloud strategy at CockroachDB?
Sure. So first, just to lay out the product lineup explicitly, we have four. There's four basic ways to get CockroachDB. The first is CockroachDB Core, which is essentially our open source edition, in which you download. You can download the source code or the binary and just run it yourself. And this is always free. We're open source with an asterisk. We do have a license restriction that prevents using CockroachDB Core in commercial database as a service. But for any other purpose, you can use it, download it, and use it for free as much as you want. Source is all there. You can modify it, recompile it, whatever. And we also have CockroachDB Enterprise, which adds additional features for a licensing fee. And this includes features like geopartitioning and other features that are especially useful in geographically distributed deployments. It includes change data capture for streaming changes from the database out to Apache Kafka and from there into other parts of your company's data systems. And also integrations with single sign-on and other things that may be important in corporate environments. So those are our two self-hosted options for CockroachDB. And then in the cloud, we also have two options. Here we have CockroachDB Dedicated, which is similar. It's essentially equivalent to what you would get in the self-hosted product, where we just run. You get dedicated VMs in a totally isolated environment running CockroachDB Enterprise just for you. And so that's kind of our premium cloud offering, since it gets you all of the all the best experience you could have from hosting yourself, except we do it for you. And then we have, as I mentioned earlier, CockroachDB serverless, which is the kind of the entry level product, which is currently in beta, but it lets you run a very small run on a small scale and then grow out as you need to. This is implemented as one or more large CockroachDB clusters run by Cockroach Labs, and then a separate front end process per customer cluster, which gives you access to a slice of the resources on the back end cluster. And so this is how we're able to keep the operating costs low enough that we can offer a generous free tier in the serverless product, and then you can scale up and pay as you go from there.
So I guess the interesting thing, you know, from evolution of databases is if you've got your single monolithic database running on your own hardware, you know, which is where I started in the industry, and probably you too, you know. And you're responsible. I was a DBA for a long time. You're responsible for every aspect of that operation. And then, you know, incrementally you move into the cloud where you're less responsible for sort of like a little bit of the hardware. And then you get to a cloud system in which the scaling is sort of managed for you. So a lot of your DBA tasks are gone, backup tasks are gone. And then you get to serverless, and where, you know, amazingly, just about all the tasks are gone, you know, like as long as the implementation is good at the back end, it will scale for me as my demand grows, and I don't even have to lift a finger. You know, I just have to. I guess I have to lift a credit card, but that's all. And it's a very attractive option, I think. And you guys have pulled it off so far as I can tell very well, right? You know, like the experience. I haven't run a serverless at scale yet, but there's a few cases, I imagine, where you're a sort of like a very large organization where you'd want a dedicated cluster so you could be sure that, you know, you had control over exactly how much resources you were applying, that you could be really prepared for spikes in load and stuff like that. But for your average application, I can't imagine that serverless isn't the future way that almost everyone will consume database services, because it's just eliminates so much of the human cost of using a database. It's a very exciting move. You know, CockroachDB is one of a couple of companies that are offering truly serverless options for consuming databases, and you know, it's well worth checking out. And you know, I'll just say my personal opinion: if you're going to get started with CockroachDB as a developer, you can either sort of like do, if you're on a Mac, brew install, or you know, if you're something similar, if you're on Linux. But, you know, the serverless option makes a lot of sense and is just as easy to get started with. You know, that's the way I prefer to work with it at the moment, having sort of like, you know, gone through the ringer with you writing the book, you know, experiencing all of the overhead of running a self-hosted cluster. You know, there's a lot to be, you know, it's a lot of fun setting up clusters if your mind works that way, but it's not productive to be trying to replicate the expertise that the Cockroach team have at the back end. So anyway, that's a little bit of a sort of like an ad for serverless, you know, no charge for that, Ben. One other thing I'm interested in as someone who sort of like hangs around databases a lot is the sort of like the perennial split between the operational databases and the analytic databases. So for a while, we sort of had one size fits all databases, you know, up until about 12 years ago, 15 years ago. Data warehouses, there were some specialized data warehouses, but there were also sort of people running data warehouses on Oracle, SQL Server, Oracle and SQL Server were used as operational systems as well. And, you know, we had this sort of period where SQL went out of fashion, and now SQL is definitely back in fashion. But we've still got this split between operational and analytic. And, you know, in the modern world, I'd say that split is most sort of like best illustrated by Snowflake DB, which just recently had one of the largest software IPOs of all time. I think it actually is technically the largest software IPO of all time, which is an analytic database running in the cloud, fully supports SQL. And then we've got operational SQL distributed databases, CockroachDB being the sort of probably flagship representative of that class of database. But they've split, you know, there's sort of, we have different workloads that each are sort of like optimized for. They both can do a bit of each other's sort of processing, but they're clearly optimized for one or the other. Do you think those two worlds are going to sort of pull back together at any time soon, or do you think we're, for the time being, you want to choose a different platform for when you're analyzing data than for when you're sort of like doing high-speed transactional processing of data?
Yeah, so I think this this division is going to continue to evolve. I mean, it's not a bright line between the two classes of applications. This is something that we saw early on when we were developing CockroachDB. We wanted to be very explicit, telling people, just as I said that we, early versions of CockroachDB had warnings not to do too much with joins. Even after that limitation was lifted, we continued to tell people that, well, we're not an analytics database. Don't expect us to be able to, be best in class performance at these analytics types of queries. But as a database vendor, this is, yes, transactional databases and analytics databases are a different category. To a customer, it's not that clear. Some customers are very rigorous about separating their analytics off into separate systems. Others are not. They'll just run their, analytics style queries on their main database. And so, there's still an expectation that those things will work reasonably well. And so we've done our best to try and do that kind of query the best we can. But when it comes right down to it, the kinds of technologies that you want for analytics processing are very different from what you want for transactional processing. For transactional processing, you want, for example, row-oriented storage, while analytics tends to want columnar storage. That said, even though the technologies may be different, you may have a single database product that provides both. I think that there's definitely a possible future in which CockroachDB replicates all of your data multiple ways anyway. If Cockroach could keep some of those replicas in columnar format and some in row format, and then send queries to one or the other depending on what that query needs, that would be a way to get kind of a best of both worlds under one roof kind of situation. So I think there's definitely room for evolution like that. But the history of this industry is littered with companies that have said, okay, we're going to be the only database solution that you need. We're going to be good at everything, and therefore we don't need to be good about integrating with other kinds of database systems. And that has just been demonstrated time and time again to be the height of hubris, and leads to a fall. So. I don't want to say that CockroachDB is going to be the ultimate unification of transactional and analytic workloads, but I do think there's going to be a continual kind of blurring of the lines and evolving to handle more and more kinds of specialized workloads.
Yes, yeah. So there are a couple of companies that are trying to do a sort of a hybrid job. And it seems to me they have to double up on their engineering effort to be good at both. And even then, they're usually not the best at either of those two things, so that they tend to come into competition. There's usually one of these two requirements, which is the primary one, that's the decisive requirement, and they fail at that decisive requirement. It's all very well. As you said, like you've got to focus in software engineering. You can't afford to sort of like have too many threads of effort, because you'll just end up sort of failing at some of them. And
yeah, you have to focus kind of on both sides of the divide. So as the database vendor, we've chosen to focus on operational transactional needs, but also as a customer of a database, you have to kind of choose what areas of your data you're going to try and optimize, and where you're going to essentially spend your operational budget. So when I said, some companies are just fine running their lightweight analytical queries on CockroachDB, if you look at it from that company's perspective, if you're a little startup and you're running CockroachDB, are you going to want to set up Kafka and Snowflake and deal with integrating these three systems? I mean, sure, you can get you'll get a better analytics experience with Snowflake than you will with CockroachDB today, but it's a much higher operational cost just to have to deal with that many different moving parts. And so that's another factor that I think that you have to kind of pick your battles and decide when you're going to spend that operational complexity. And I think that when you look at the amount of money that some companies, your larger enterprises spend on data of all kinds, yeah, it makes sense there to really optimize and make sure that you're getting best in class performance for every kind of subcategory of data. If you're not operating at that scale, then that's when the more hybrid solutions are appealing, even if they're not individually best in class at any particular task.
Yeah, that's a good point. You always, data's never just there to be processed. There's always some analytic reporting or similar function. And in CockroachDB, for people who aren't familiar with it, one sort of thing I learned while participating on the book is that when you're wanting to read large amounts of data from Cockroach, you can use the as of system time clause to read it from a snapshot that avoids all of the transactional consistency overhead, and which results in a sort of like a much better outcome, because otherwise CockroachDB will actually, I might be about to mangle this, Ben, but CockroachDB will try to give you an absolutely consistent view of the database as it is right now, and if there are concurrent work going on, then CockroachDB may continuously sort of like bump that statement to try and sort of get the most recent data. But if you say as of system time, 5 seconds ago, it can just sort of like ignore all that and just go with the MVCC snapshots that are sort of like consistent, but not absolutely up to date. That's one of the interesting things about CockroachDB, that the use of that clause to optimize your processing is something that's, I think, fairly unique to Cockroach, at least something I haven't seen in other databases, but it's an important sort of technique. It's a bit nuanced, but it's an important way to sort of optimize processing.
Yeah, this particular technique, this is the as of system time clause, which we informally call the time travel clause, to let you run a query as of 5 seconds or 10 seconds ago. That particular feature, as far as I know, is unique to CockroachDB. But a lot of what you can do with it is similar to what you can do in other systems using marking the transaction as read only. So that it's common in a lot of systems. If you mark a transaction as read only, maybe that sends it to a read only replica instead of to the primary. Right. And that is kind of functionally equivalent or functionally similar to what you're getting with the as of system time clause. The nice thing about the as of system time clause is that, especially with the new feature that we just introduced called bounded staleness, where you can say give me the latest data you have, as long as it's no more than 10 seconds old. For example, that would let it send your query to the physically nearest replica to you, get whatever data it has. But if it sees that replica happens to be really far behind for some reason, then it will fall back to getting fresher data from a remote replica. Yeah, and so it gives you a way to fine tune exactly how much stale data you're willing to tolerate for your application.
Yeah, as of system time is awesome too, because it lets you do a sort of like a get out of jail free card type thing for screw ups. You can sort of delete all the rows out of the table and and then you can just use as of system time to get them back, and you can even do a backup of the database after you've ruined it. Which if I'd had that when I was a sort of a young DBA, how much easier my life would have been. But that's another story.
Yeah. This is one of the features that blows people's minds when they first see it.
What are the other things in CockroachDB that developers should know about, or if you sort of wanted to let people know a few things that they might not know about that would help them in their life, what would they be?
We have these multi-region features for running a database distributed across multiple physical locations, and in that, as a part of that feature set, you have the ability to mark tables as either global or regional. And the way that global tables work is actually really neat. There's a lot of magic under the hood, but when you write to a global table, it effectively writes to that table kind of as of system time in the future, instead of the normal uses of as of system time to write into the past. and so the write goes into the future, and then it doesn't. And then it kind of takes effect when real time catches up with when the write was scheduled to happen, and so that gives you. So as we mentioned, as of system time is a way to make as one way to make read queries not interfere with writes. This is another way. You can have, instead of pushing your reads into the past, you can let your reads stay at the present and push your writes into the future.
Wow. Yeah, that's fantastic. So I guess we're coming towards the last part of the conversation. Maybe we should talk a little bit about the book. For people who've read O'Reilly Definitive Guides, I don't think you'd be surprised at the kind of layout of the book. It tells you everything that you need to know to run CockroachDB locally in the cloud, sort of reference to the SQL language, programming practices, a lot of stuff for administering if you're administering on-prem, and for that matter, if you're administering in the cloud. But there's, as we talked before, there's a lot less. Ben, what would you say to someone who's sort of looking at the book, thinking about getting it? What do you think the book sort of offers that isn't there in the documentation? Because the documentation for CockroachDB is pretty good. So what's the role of technical books in today's sort of online age?
That's a
tough question because there's a lot on there, isn't no one.
Right, docs are very good, and they're always getting better. So it is a tricky question to answer. But I think the big thing that a book has that most online documentation doesn't is just a kind of linear flow. Like you can't very well go to the CockroachDB website and read through all of our docs in order, but you can go to the book and you can identify the section that you want, whether that's kind of the introduction or the deep dive into CockroachDB architecture, or we have a run of chapters for the application developer and a separate run of chapters for a database administrator. You can pick up the section that kind of fits your needs and read that straight through and get pretty comprehensive coverage. Which is a little harder to do in most online documentation. It's harder to figure out which parts you need to read and when you can be sort of done. That's the big thing that's missing. That there's the online documentation never ends. You can always find more, but with a book you have at least a reasonable estimation of what the important part is, and then when you've finished that much, then you're in a pretty good place.
Yeah, I'd agree. I think this is more for you want to learn the core techniques, and we tried hard to future-proof it by not bogging down in the sort of like the latest syntax, but it sort of like runs you through what you need to know in a sort of like a well-organized manner. I've bought a lot of technical books, and when I started, the technical book was there because there was no internet, and so I had Unix in a nutshell, so I could look up Unix syntax commands. That's not the role of books today. It's more, I think, you want to sort of like fast track yourself into a new technology, and the book has all the information collated, curated, and presented in a nice way for you to master the topic in the minimum amount of time. And I think that's what I'd recommend, why I'd recommend people get it. So Ben, have you got any questions you'd like to ask me as co-author, or we're just wrapping up? Anything you'd like to say that we haven't mentioned?
Yeah, I come to this as a founder of the CockroachDB project and company, and so I have very much an insider's view on how all of this works. But I'm curious to get your perspective as an outsider coming to CockroachDB for the first time. For the purposes of this project, do you have any comments about CockroachDB from that perspective? Anything that surprised you, whether it was good or bad?
Yeah. So just to sort of put that in a bit of context, I've been working with databases since the 80s, and spent a lot of time with Oracle, MySQL, fair bit of time with MongoDB over the past few years, and I'm a real sort of fan of databases. I don't really care what sort of model they have, or whether they're simple or complex. I'm generally sort of like them for what's good and sort of try and gloss over what's not so good. I was really happy to see CockroachDB emerge as a leader because it was pretty obvious that the SQL language had been thrown out of products like Cassandra and others, not because there was anything wrong with it, but because it was associated with strict transactions, which the founders thought needed to be discarded in order to achieve some availability and performance goals. And so I was happy to see SQL make a resurgence, and I was even more happy to see that I could come back to a modern database that was respecting consistency and transactional integrity, because anyone who's worked with non-transactional systems knows you can get things done, but you have to write an enormous amount of code just to protect yourself against inconsistencies. You don't know for sure that you're going to read your own write, or you don't know for sure that something that you've written is even going to persist in the database, and that makes for a lot of fragility in code, and so you have to have extra testing and redundancy and so forth, and that sort of stuff stripped away with CockroachDB. And I was very impressed with how easy it was to get started with. It is a very sophisticated. So I was impressed on two. That was one. I was impressed with what you guys have achieved over a relatively short period of time in terms of having a sort of an architecture that's best in class for distributed systems. And at the same time, I was impressed with how easy it was for me to get started. So the fact that it was Postgres compatible meant that I didn't have to learn, really any sort of like new programming paradigms, or very few anyway. The SQL language was complete. There weren't sort of like big missing chunks of SQL that I had to sort of work around. So I could hit the ground running developing an application. And at the same time, I had this sort of like very sophisticated, scalable thing behind me that was, ready to go anywhere. And so, I know it sounds a little bit like congratulating myself on having, collaborated with you on the book, but I am an outsider. I've worked with all the different database, or a lot of different database platforms, and I think CockroachDB is a fantastic achievement. You should be very proud of it. And I think it's only, going to get better. I'd like to think we did a good job with the book. If you're wanting to get started with CockroachDB, you check out the book. You can have a look at it at the O'Reilly website. I'm not sure when this podcast will drop. It'll probably drop around about the time the book is fully available. But if not, you can pre-order and you can look at the early adopter version, which contains pretty much the first half of the book, which is the developer stuff, getting started, installing, SQL language features and things like that. So probably, by the time you've consumed that early adopter bit, the rest of the book will be available. You can visit the Cockroach Labs website to get a free CockroachDB serverless account if you want to play around, or you can download it using the sort of typical download things like Brew or apt-get on Linux. And so, yeah, I'm sorry, I rambled away from your question into a sort of a wrap up, but I've really enjoyed working on the book. Writing books is not sort of like necessarily a sort of lucrative a financial thing, but it is a great way to learn, about a new technology, and I'm all about learning. So really enjoyed working with you on the book, Ben, and I recommend it to anyone who's interested in CockroachDB. It's a pleasure working with you. Yeah,
thank you. It's been a pleasure working with you as well. I also want to take a moment to recognize here our third co-author, Jesse Seldess, who's not with us on the podcast today, but he also worked very hard with us on this book over the course of the last year.
Absolutely, and Jesse is responsible for the excellent online documentation and educational content at Cockroach Labs website. So, we couldn't have done it without him, that's for sure. Okay, well, that's a wrap, I guess. Thanks, Ben. Enjoy the rest of your day. And thank you guys for attending the podcast, and let us know what you think. Bye.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.